So good morning, everybody. This is Math 0310. It's February the 6th. A couple of announcements that I need to start off with today. First of all, this is an exam week, so that's a big deal as we go through the rest of the week. The window for the exam is February the 8th through the 13th. I've been having a lot of questions by email and remind messages about the exam. Remember, you can, unless you have worked it out with me in advance, you can take the test in any testing center in the Lone Star system. You don't need to make an appointment to take the test. You do need to make sure you know what hours the center that you're going to use are open. And, so touching base with them would be good. Or if you email me, I can find the hours out for you also. The hours vary from college to college a little bit. So make sure you're aware of that. Time limit on the test is 2.5 hours. You should not need 2.5 hours to take the test. Most of you should finish the test somewhere between an hour and an hour and a half. And I would plan on probably taking about an hour at least to take the test. But you ought to allot yourself about 2.5 hours. So in case you hit something on the test that really throws you for a loop, you have a little bit of time to struggle on a problem or two and still not feel too pressured for time. A scientific calculator is allowed on the exam, a scientific calculator or a four-function calculator. No graphing calculators on the test, but you can bring in either a scientific or a four-function calculator. So no graphing calculators here. And let's see. No notes are allowed. No formula sheets, nothing like that are allowed when you go take the test. So make sure that you're aware of that. The test is a paper and pencil test. It's not multiple choice. It's not on WebAssign. It's just a very traditional math test. You go in and you work problems on the test itself, and you'll turn in that test. Online office hours the rest of the week. I'll have online hours today from 11 to 12 and tonight from 8:30 to 9:30. And then again on Sunday from 8:30 to 9:30. On campus hours. I will be on campus tomorrow from 4 to 6 p.m. and Thursday from 9 to 11 a.m. So those will be my office hours for the next 2 days, Wednesday and Thursday. So tomorrow and then the day after that. My office is on the North Harris campus, Winship 115K. So you do not need to make an appointment necessarily to come by and see me. It's not a bad idea to shoot me an email or a remind message to say that, hey, I'm gonna be there at such and such a time, but you don't in general need to make an appointment to see me formally. You can make an appointment to see me online in my WebEx office at other times besides the times that I have listed there. And I have had a couple of students over the past week or two who've made an appointment and have gotten together with me in the WebEx office outside of the regular hours. So email me if you want to try to do that, and we'll see if we can come up with a mutually agreeable time. So. All right, so before I get started on material, does anybody have any questions just about this stuff? For you guys who are with me live here, do any of you have any questions about any of this information right here as we're going into the test?
No.
Anybody else?
No.
Okay, so I guess everybody's okay then. So it should be pretty straightforward as far as taking the exam, and you'll get used to going into the testing center and taking the test and all that. And by the way, one other thing which I didn't mention is you do have WebAssign homework to do on February the 11th, section 7.6, and then you have an assignment that's 8.1 and 8.2 combined. So make sure that you pay attention to WebAssign due dates. Typically, for the rest of the semester, not every week, but just about every week, you are going to have a couple of assignments due on Sunday evening. So kind of keep that in mind as we go through the semester. Try not to get behind on WebAssign homework. It's easy to get behind on that stuff, so try to keep up with it and work on it every week as we go through the semester. Usually you have 2 or 3 assignments due every week for the rest of the semester, so kind of keep that in mind also. All right, so today we continue talking about, remember we have been talking about rational expressions, and so today we're going to look at a specific kind of rational expression called a complex fraction and talk about how to simplify a complex fraction. So that's our goal today. We've just come out of multiplication, division, addition, and subtraction, right? So that's what we have done on rational expressions. And as far as your exam goes, exam 1 does cover section 8.1 on simplifying rational expressions, 8.2 and 8.2 on multiplication and division of rational expressions, and then 8.3 and 8.4 on addition and subtraction of rational expressions. That's all rational expressions right there. And that will all be on exam 1. The material I'm covering today on complex fractions will not be on exam 1. That will be the beginning of exam 2, simplifying complex fractions. All right, so first of all, let's talk about what a complex fraction is. The name does not sound too inviting, does it? It sounds like it's going to be something that could be difficult because you've got that word complex in there. The word complex simply is implying that you've got a fraction that has fractions in it. That's basically what you're talking about. A fraction that has fractions in the numerator and or the denominator. For those of you who are going to go on to college algebra, you're going to need to be able to deal with rational expressions and be able to simplify them. For those of you who are, like for example, business majors, you have to go on and take business calculus, and you're going to deal with rational or complex fractions in various different places when you're dealing with algebra. And anybody who's going any further beyond this class in algebra is going to deal with complex fractions. So you've got to get ready for that. Now, a complex fraction could be as simple as something like this. It could be something like 3/4 over 1/6, right? That's an example of a complex fraction. And in a situation like that, where you just have a fraction over a fraction, this is really not that bad because this is just, all this is another way of writing the division problem, 3/4 divided by 1/6. Because remember that fraction bar is really a division symbol. And so all you're really saying is 3/4 divided by 1/6. And then you've got the rules for multiplication and division. And so 3/4 divided by 1/6 becomes 3/4 times 6 over 1. And so you've got 18 over 4 or 9/2 as the simplified version, right? So a simplified version of a complex fraction is writing the fraction so it's not a complex fraction, right? So this is a complex fraction right here. This one is simple right here. Right? Simple fraction means one that doesn't have fractions in the top or the bottom. And that's what simplifying means. When you're talking about a complex fraction, you're talking about taking something that's complex and writing it so that it's something that's simple, right? And so that's what we want to talk about doing. And so we've already done that now with a problem like this. If you have just a single fraction over a single fraction, right, all you do is invert and multiply to simplify it. So x plus 1 over 3 over x minus 5 over 6 is an example. A little bit more involved, but it's really the same problem we just did, right? And so you could rewrite this as a multiplication problem, as x plus 1 over 3 multiplied by the reciprocal of x minus 5 over 6, right? Because you're inverting and multiplying, right? So what do y'all notice that what did I do? I inverted that second fraction, right? Because it was x minus 5 over 6, and now it's 6 over x minus 5. But what did I do? I changed the operation to multiplication instead of division, right? Which we know that's how you do a division problem. So, so this would be 6 times x plus 1 over 3 times x minus 5. And then you could divide out the 6 and the 3 because those are both involved in multiplication problems. So those both divide out. Then you're left with 2 times x plus 1 over x minus 5, like that. So if you just have a single fraction over a single fraction, you know, this really shouldn't be too big a deal as far as simplifying a complex fraction, because it's just inverting and multiplying is all it is. Now, if you if you have something like this, 2 over, let's say, 8 over x squared minus 9, like that. Now notice this one has a fraction in the denominator, but not the numerator. You have to be careful here, but notice the big fraction bar is there underneath the 2, and then there's a little fraction bar that's in this fraction right here, the 8 over x squared minus 9. So this is technically going to be 2 over 1 over 8 over x squared minus 9. So if you have a complex fraction where either the numerator or the denominator is not a fraction, then you ought to write it as a fraction so that it looks like the rest, you know. And so you get, what's this going to be now? This is going to be 2 over 1 multiplied by x squared minus 9 over 8. Right? And what did we do? We changed the operation to multiplication. We inverted the fraction in the denominator there. And then the 2 and the 8 can divide out. We can divide a 2 out there, which will leave me with a 4. And so the simplified complex fraction would be x squared minus 9 over 4. Now the x squared minus 9 is factorable. And at this point, there's nothing there's nothing to simplify. There's nothing to divide out at the end there. So either one of these last answers would be acceptable as the simplified version. And so again, what did we do? We started with a complex fraction. Something was complex, and we ended with a simple fraction at the end. That's what we're trying to do here. All right, so that should not be too big a deal. The issue is that, and it always seems like in algebra, right, that there's an issue. There's another shoe is about to fall somewhere. And with complex fractions, this is true. When you've got a fraction divided by a fraction, you just treat it as a division problem, and you invert and multiply, and you're done, right? It's pretty easy to simplify it. But if it's not a simple fraction over a simple fraction, so like if you had 2 plus 1 over x over 3 minus 1 over x, like that, this is not a complex fraction where you can just invert and multiply, right? This is not just a simple fraction, just a single fraction divided by a single fraction, right? It's not in that form. So you cannot just invert and multiply here. But that doesn't work anymore because you've got an addition and a subtraction problem in the numerator and the denominator here. And on the first few problems, I didn't have that, right? But I've got an addition and a subtraction problem here, and so I cannot just invert and multiply in a problem like this. So this is the kind of the bulk of what we want to talk about in this section is how do you simplify a complex fraction that has addition or subtraction in the numerator and the denominator. All right, and so in this problem, we still want to try to write this as a simple fraction. The question is, again, how are we going to go about doing that? All right, so the idea here is to go ahead and clear the fractions out. And so what we're going to do is first write every term as a fraction. Now let me show you what I'm talking about. So first, write every term as a fraction so that they all kind of look kind of parallel, kind of like the same thing, right? So you have 2 over 1. So notice instead of writing just 2, I'm going to write 2 over 1. Write it as a fraction. Plus 1 over x, and then 3 over 1 minus 1 over x. Like that. So write everything, all the little pieces as fractions. Right? And then what you're going to do is you're going to find the least common denominator for all the fractions. So write every term as a fraction. That's step 1. Step 2, find the LCD for all the fractions. It doesn't matter where they are. Find the LCD for all the fractions. And we know how to do that because we were talking about that last time when we were looking at addition and subtraction problems. And remember, the idea there is to build the LCD by using all of the factors that you can see in any of the denominators. So in our problem, the only factor in the denominator is an x. And so that's the only factor I need in the LCD. And it's also just raised to the first power everywhere. And so that's my LCD. It's just x. Step 3. What you're going to do here, and the best thing to do is to actually draw this out. Here's your complex fraction, like this, is you're going to multiply the numerator and the denominator by the LCD over 1. You're going to multiply the numerator and the denominator by the LCD over 1. Now remember that is legal to do because we have this equivalent fractions property that says that as long as you multiply both the numerator and the denominator by the same thing, that's legal to do algebraically. And so in my problem right here, I'm going to actually write this out as a separate step. So if you go back and look at this, you'll kind of see the process here. So what I'm going to do is I'm going to put parentheses around the numerator and the denominator, and I'm going to multiply numerator and the denominator by the LCD over 1, like that. All right, and the reason why I want to put parentheses around the numerator and the denominator, besides the fact that it's correct to do that, but it also emphasizes that you're using the distributive property to multiply this out. Right, so what I'm literally doing is I'm taking x and I'm multiplying it by both of these terms. And I'm taking x and multiplying it by both of those terms like that. All right, this is just the distributive property in both cases. So do that. Let's multiply. Let's see what we get. So you're multiplying fractions in every case, so it's just multiply the numerators and multiply the denominators. And what I would do is I wouldn't even worry about canceling stuff out right now. I would just multiply, and then we'll cancel stuff out afterwards. So this is 2x over 1 plus x over x. Whoops, so x over x. And this is over 3x over 1 minus x over x. And y'all see that what I did is I multiplied every fraction by x over 1. Do you see that x that's sitting in the numerator of each one of those fractions? It's because I was multiplying everything by x over 1. And then what happens there? You get some canceling, right? Now 2x over 1 is just 2x, but x over x is 1 because those divide out. And 3x over 1 is 3x, and then x over x is 1. And what have I got? Boom. What kind of a fraction is this at the end? This is a simple fraction. What did I start with? I started with a complex fraction. And so what have we done? We have simplified this complex fraction. We've written it as a simple fraction. that 2 plus 1 over x over 3 minus 1 over x is equal to 2x plus 1 over 3x minus 1, that they're the same thing, right? That they're equivalent expressions. All right, so we've got the kind of like a four-step process. It's write every term as a fraction, find the LCD for all the fractions, multiply the numerator and the denominator by the LCD over 1. So LCD over 1 over LCD over 1. And then step 4 at the end is to multiply and simplify. Now in this problem, there was no simplifying to do. There was nothing to divide out, but that may not necessarily always be the case. So, all right, so for those of you who are watching live today, make sure that you shout out if you have a question about something as we're going through this, because we're going to get to look at some more complicated problems. So, everybody is okay with that problem? Nobody is shouting at me. So I think we're okay. All right, so the next problem. Let's say we have 3 over x minus 2 over y over 3 over y plus 1 over x. Okay, so in this problem, everything is written as a fraction. All the little terms are written as fractions, so we're okay there. And so what we're trying to do is simplify the complex fraction, right? So we find the LCD next of all the little fractions that appear in there. And so there's 4 fractions in there, altogether 4 little fractions in there. And there's an x, I see an x in the denominators, and I see a y in the denominator. So there's got to be an x and a y in the LCD, and there's no powers on the x and y, so that's it. That's my LCD. And so now what am I going to do? I'm going to take the numerator and the denominator, and I'm going to multiply both of these. Remember, the equivalent fractions property says it's okay to multiply a fraction by the same thing in the numerator and the denominator. What you're left with is an equivalent fraction to the one that you started with. So this step right here is legal to do, what I just did. And now we're going to multiply and simplify. Now remember what I talked about a second ago, is that what you're doing here is, is you are using the distributive property to multiply this out. Right? So you're multiplying xy over 1 by every one of those fractions. All right, so let's just write it out. Let's not worry about canceling anything or dividing any factors out. Let's just multiply it out. So you have 3xy over x minus 2xy over y divided by 3xy over y plus xy over x. And again, notice that every one of these fractions I multiplied by x times y. You see the xy sitting in every one of those. Right? So I'm just using the distributive property to multiply through by xy over 1. All right. So now we've multiplied, right? And so now the last thing to do is to simplify. And there's simplifying to go, right? And if you've done this right, all the little fractions should cancel out. So notice the x's divide out in that fraction. And then the y's divide out in that fraction. The y's divide out there. And then the x's divide out there. Right? And so you are left with 3y, technically 3y over 1, because the x divided out there, but I just write 3y, minus 2x, and that's divided by 3x plus y, like that. Now, don't forget that I cannot divide those 3's out at the very end there. That's not allowed to do because I have addition and subtraction there. And so that's the simplified fraction, right? We started with a complex fraction right here, and we finished with a simple fraction right here, and that simple fraction is reduced. There's no common factors. And so that's the simplified version of the first fraction right there. All right, so hopefully we are doing okay here. Next problem. Let's look at something like this. Let's say we have 1 over x squared minus 1 over y squared divided by 1 over x plus 1 over y. All right, let's see what we get here. Let's see how this works out. Now, all the little pieces are all written as fractions, so we're okay there. And so now what we want to do is we want to see if we can clear the fractions out. So we've got to build the LCD. Everything is written as a fraction, so we're building the LCD. The only factors we see in the denominators here are x and y. If you look at all the little fractions in there, all you see in the denominators are x's and y's. So that means I've got to have an x and a y in the LCD. But this problem, unlike the first few we did, there are exponents on the x and the y, and so you do have to raise them to the largest exponent. And so the LCD in this case is x squared y squared. And that's what I'm going to do here is I'm going to take the original fraction and I'm going to multiply numerator and denominator by x squared y squared over 1. Right? So this is going to be multiplied by x squared y squared over 1, and the denominator is going to be multiplied by x squared y squared over 1. Right? Remember, you have to do, and this is really, really common for me to see students do this, is to multiply the numerator and the denominator by different expressions. And remember, you're not allowed to do that, right? That's illegal to do algebraically. Using the equivalent fractions property, you have to multiply both the numerator and the denominator by the same thing, or you don't end up with an equivalent fraction. All right, and then, so now we use the distributive property to multiply this out, right? So that's our next step. You know, I try to, I don't know if these arrows here are distracting or not, but I like to draw them because it's really emphasizing the fact that you're using the distributive property. It kind of helps you keep things straight a little bit. So we do that. We multiply everything by x squared y squared over 1. So that gives me x squared y squared over x squared minus x squared y squared over y squared all over x squared y squared over x plus x squared y squared over y. Now, some of you may try to use fewer steps in a problem like this, you know, and I tried to get after you in the last lecture when we did addition and subtraction about the fact that this is not some kind of a competition where you're trying to work use as few steps as possible to work the problem. That's not what you're trying to do. And also, you know, my guess is you're not trying to save paper. Or at least from my view, you can, in your life, you can save paper all sorts of ways. But you doing your math homework is not a place to save paper, right? So you want to use lots of paper, write lots of steps down. That's the way you want to approach this. All right, so we go through and we divide stuff out, right? There is a bunch of things that cancel out here. The x squares divide out in that first fraction. And then the y squares divide out in that fraction. And then notice in the denominator, one of these x's divides out. I'm still left with an x. And in the second fraction, one of the y's divides out, and I'm left with a y. So now we write down what we have left. And so in the numerator, we've got y squared minus x squared. And in the denominator, we have xy squared plus x squared y, like that. Now, it is super, super tempting to say, hey, I can cancel those y squares and those x squares at the end. You can't do that, right? Because you can't divide out terms or parts of terms. You're not allowed to do that. You can only divide out factors. The equivalent fractions property says it's got to be multiplication. And so I can't simplify this one directly, but I can do it indirectly because the numerator is factorable. Y squared minus x squared is the difference of two squares, and it factors y plus x times y minus x, right? It's a squared minus b squared. And in the denominator, there's a common factor of xy, and when you take that xy out, you're left with y plus x. And hey, notice in this problem, look, I am left with a common factor. Y plus x does divide out. And so this one did simplify at the end. And so you are left with y minus x over xy. And that would be the simple version of the original fraction, right? This is now a simple fraction at the end, trying to emphasize that we're starting with a complex fraction and we're finishing with a simple fraction. Right, I really try to emphasize that that's what you're doing when you're simplifying a complex fraction. All right, so hopefully everybody is good with that problem. So I'm not hearing any questions at all. So I am assuming we are so far so good. Okay, so the next problem I want to look at, let's look at another one here. Let's say I've got, this one's going to look a little bit messier. We've got 1 minus 2 over x minus 8 over x squared, all divided by 1 minus 9 over x squared. I'm sorry, and that shouldn't be 9x squared right there. I apologize. That should be 16 over x squared. That's better. Yes, thank you. All right, so now there are 3 fractions in the numerator and 2 fractions in the denominator. That doesn't really matter. You're doing exactly the same thing that we've done before. Now, remember what we've talked about is write everything as a fraction. And so I would take the time to do that on this problem. You know, those 1s at the beginning really are 1 over 1. And I'd write them that way. That way, every little term looks like a fraction. It probably just helps things, keep things straight, I think. All right, the LCD, the least common denominator. The only factor I see in any of the denominators is x. But the x is raised to the second power. And so the LCD has to be x squared. Right, and so what I'm going to do here is I am going to multiply the numerator and the denominator. I put parentheses around the numerator and the denominator, and I'm going to multiply each of them by x squared over 1, like that. All right, so now we use the distributive property, right? And so we distribute the x squared through there. We distribute the x squared through there. And I am not going to worry about doing any canceling here. I'm just going to multiply that out using the distributive property. So you've got x squared over 1 minus 2x squared over x minus 8x squared over x squared. And then that's divided by x squared over 1 minus 16x squared over x squared. And again, you know, you've used the distributive property, so you can actually pick out what you were multiplying by here, right? I was multiplying by x squared, and notice there's an x squared in every one of those fractions, right? I multiplied every little fraction by x squared over 1. And now we go through and we divide things out. Now, in the numerator, the first term is an x squared over 1, so that's just an x squared. And in the denominator, the first term is x squared over 1, so that's just an x squared also. But there is some dividing I can do in all the other fractions here. One of these x's divides out, and both of these x's divide out. So, and then in the denominator, the x squares all divide out. So what I'm left with here is x squared minus 2 x minus 8, and that would be divided by x squared minus 16. Okay? And now that's a simple fraction. There's no question about it. Now it's not simplified completely, right? Because I haven't reduced that at the end. It is a simple fraction. It's just not simplified. Because I can factor the numerator, right? The numerator factors as x minus 4 times x plus 2. The denominator factors as x plus 4 times x minus 4. It's the difference of two squares. And sure enough, I am left with an x minus 4 that's common. And so this fraction did simplify, and you're left with x plus 2 over x plus 4, like that. And there's our simple fraction in simple that's in, excuse me, sorry. This is in simple form right here, right? That's a simple fraction simplified. This was our complex fraction at the beginning here, like that. That's what we're trying to do, right? Start with something that's complex, finish with something that's simple here at the end. All right, so far, not getting any questions. So I'm going to look at something that's going to look horrible, maybe, and see what you think. So this is actually, I'm in section 8.5 of your book on page 947. And this is problem number 282. So the problem is that 3 over x plus 6 plus 5 over x minus 6. And then that's all divided by 1 over x squared minus 36 plus 4 over x plus 6. Yikes. Right? That is it looks like a messy problem for sure. That's it, that's certainly a complex fraction, but we're trying to simplify this thing, so that's what we need to try to do. Now, all of the little pieces are written as fractions, but if we're going to try to find the least common denominator here, we have to factor all the little denominators, and there is some factoring to do here. Now, the 3 over x plus 6 is fine, and the 5 over x minus 6 is fine. But in the denominator, that 1 over x squared minus 36 is factorable, right? That's the difference of two squares. And so you've got 1 over x plus 6 times x minus 6 there, and then 4 over x plus 6. Yikes, so that's a messy problem to write out. And so the least common denominator, remember how you do that, is you find all the denominators in all the little fractions, or all the factors that are in all those little fractions in the denominator. And there's only two factors that are present down there. It's x plus 6 and x minus 6. So you're going to use both of those factors in the LCD, and then none of them are raised to a power, so that's the LCD. Just x plus 6 times x minus 6. And so that's what we're going to do, is we're going to multiply numerator and denominator by x plus 6 times x minus 6 over 1. Like that. And we're going to use the distributive property to do this, right? To multiply through. Like so. So in the numerator, and I know this is kind of a hassle to write out all these factors and everything, but I'm going to go ahead and write the whole thing out. So in the first fraction, you have 3 times x plus 6 times x minus 6 over x plus 6, plus, and then 5 times x plus 6 times x minus 6 over x minus 6. And then that's all divided by x plus 6 times x minus 6 over x plus 6 times x minus 6. Ooh. Okay, there you go. And then that would be plus 4 times x plus 6 times x minus 6 over x plus 6. Geez. So, you know, once again, I've been trying to do this on some of the problems. You can pick out that x plus 6 times x minus 6 in each one of these fractions. Right? In each one of these fractions, I'm multiplying by x plus 6 times x minus 6 over 1. And you can see it sitting inside each one of those fractions. Now, don't go and start multiplying stuff out here. Instead, what are you doing? You're trying to divide out common factors. So the x plus 6 is divided out in that first fraction. The x minus 6 is divided out there. Both sets of factors divide out in that fraction in the denominator, the first fraction in the denominator. And then the x plus 6 is divided out on the second fraction in the denominator. So you write down what you have left, and there's a common mistake here that I'm going to show you. But in the first fraction, we have 3 times x minus 6 plus 5 times x plus 6. And in the denominator, now the first fraction in the denominator, all of those factors divided out. Don't think that that means that it's just gone and they've disappeared. What you're saying is that you're taking a number and dividing it by itself. So you are left with 1 right there. If you don't write a 1, then it's going to be incorrect because it's not the same expression anymore, right? You're saying that x plus 6 times x minus 6 divided by x plus 6 times x minus 6 is equal to 1 because you're dividing a number by itself. And so you should get 1 right there. And then this is plus 4 times x minus 6, like that. Now don't try to divide anything out here, right, because you've got addition. And so all you can do in this problem is multiply all this junk out and then collect like terms and see if you can simplify it. So you have 3x minus 18 plus 5x plus 30. All divided by, please don't take the 1 and the 4 and add them together because that is violating order of operations when you do that, right? You've got 4 times x minus 6 right there, so you do that first. So this is 1 plus 4x minus 24, right? You do the multiplication first. So in the numerator, collecting like terms, you have 8x plus 12. In the denominator, you have 4x minus 23. If I did all that correctly, and I think I did. Now, there is a common factor in the numerator, but there is no common factor in the denominator. And so that's actually the simple form for our fraction. Now, you could take out a 4 out of the numerator, which will leave you with 2x plus 3. But that does you no good as far as simplifying the fraction. So actually, either one of those is fine right there at the end. Wouldn't make any difference how you wrote it. I'd be thrilled with you getting it to that point, regardless. So,
quick question.
You bet.
I'm trying to make sure I'm where I got lost at.
Go ahead, Tricia. You're doing good.
12. How's it with the negative 6 and positive 6?
Repeat the first part of your question again.
Okay. Where you have 3 times x minus 6 plus 5 times x plus 6.
Okay.
And you have 12.
Well, now look, what I did is I first took, in this step right here, I first multiplied everything out. So I used the distributive property here, right? And that gave me the 3x minus 18. Right there, and then I used the distributive property there, right, to get rid of those parentheses, and that gave me the 5x plus 30. Do you see what I did there, Tricia?
Okay.
And then I go through at the very end there, and I've got some like terms, don't I? I have the 3x and the 5x add to give 8x, and then the negative 18 and the positive 30 add to give 12.
Okay. Okay.
Is that good?
Yes.
Okay.
I'm at work, so I had a call and I missed that.
Well, and it is easy to get lost in these problems because they're so, they're kind of lengthy, right? And because they're so long, I think that's one reason why I like to try to write out a lot of steps, because it's really easy to get lost. And like you said, if you turned your head for a second because you got distracted by something going on at work, then you come back and you go, "What the heck happened?" Right? It's hard to keep track of where all the terms go and everything. So right, so that was the order too, and I think maybe that I could understand why you might have gotten lost right there, because the order was going from that second to last step to all the way to the bottom of the page, and then I continued on because I lost room at the bottom there, or I ran out of
Okay.
room. So, all right, so that's a good question. Anybody else have anything else they wanted to ask about there? Okay, then I have really just one last problem. We're gonna actually finish up a lot earlier today than usual, just because we're only covering this one topic today. So this is number 290, and this is gonna be the last problem we're gonna work on, unless you have questions about some things. So this problem is 7 plus 2 over q minus 2 over 1 over q plus 2. Now I did want to mention the 7 right there. That 7 is a term just like the other two little fractions. And this is why I said that the first step should be to write everything as a fraction. This way the 7 looks the same as all the other fractions. And so instead of writing 7, you ought to write 7 over 1. Right? That way it looks like a little fraction just like the other ones do. And so the least common denominator here is q plus 2 times q minus 2, like that. And we're going to multiply numerator and denominator by q plus 2 times q minus 2 over 1. Like that. Right? And I'm going to write this out just like I've been doing. I'm not going to try to short circuit this problem. So, you're using the distributive property in the numerator. Now, the denominator is not the distributive property because there's no addition or subtraction down there. So in the denominator, this is simply q plus 2 times q minus 2 over q plus 2. No distributive property there. In the numerator, this is 7 times q plus 2 times q minus 2 over 1 plus 2 times q plus 2 times q minus 2 over q minus 2. Like that. All right, so you've multiplied all the little fractions by q plus 2 times q minus 2. And then I would go through and divide out common factors. So let's see, I've got a q minus 2 that divides in that second fraction, and then a q plus 2 that divides there. And so then I write down what I've got left, and there is going to be some multiplication to do here. You have 7 times q plus 2 times q minus 2 plus 2 times q plus 2. And in the denominator, all I'm left with is just q minus 2 over 1, or just q minus 2. Now, if you've gotten this far, please don't make this mistake. Do not. Now, I'm going to undo this in a minute, but don't divide out those q minus 2's right there in those two parts of the fraction like that, because the q minus 2 in the denominator I can cancel. I could divide that out, but the numerator, that q minus 2 is part of an addition problem. And so I'm not allowed to divide that out. Right? And so all I can do here to try to simplify this thing is multiply this stuff out. Now the 7 times q plus 2 times q minus 2, how do I multiply that out? And I want you to think about how you take three numbers and multiply them together. Like if I had 2 times 3 times 4, for example. Well, how do you do that? Well, you take two of them and multiply together, and then multiply that one by the third, and you get 24. But it doesn't matter which two you start with, right? So like I could take 2 times 3 times 4, and I could take the 3 and the 4 and multiply together first, times the 2, and then that still gives me 24. right? So you can multiply in any order you want. So with that 7 times q plus 2 times q minus 2, what makes sense to do is to multiply the q plus 2 times the q minus 2 together first. Because that's just the difference of squares, and that multiplies as q squared minus 4. And then plus 2q plus 4 here at the end. And then over q minus 2. And I'm still not done. And then I can multiply the rest of the numerator out. You get 7q squared minus 28 plus 2q plus 4, yikes, over q minus 2. That's kind of yucky at the end there. And then I collect like terms. So I'm going to go try to finish the problem right here. So you've got 7q squared plus 2q. And then minus 28 and plus 4 would be minus 24. And that would be divided by q minus 2. Now the 7q squared plus 2q minus 24, you know, you're not sure whether that's factorable or not at the beginning. You know, that's something to check. Is that 7q squared plus 2q minus 24 factorable? Now the only factors for 7q squared are 7q and q. So that's good. At least we know that the first two terms just have to be a 7q and a q. And so the question is this factorable? And it actually is factorable if you put a q plus 2 right there and a 7q minus 1 right there, right? That inside 2 would be negative q and the outside 2 would be, no, that's not, that's actually definitely not right. I don't know what I'm thinking about there. Let me erase that and completely, totally ignore everything I just said, right? Because I don't know what I'm doing. So let's try that again. So you have 7q and q, and you're trying to fit in factors of 24 there. You know, so if you put a 2 here and a 12 here, which I don't think is what I did, you know, that gives you a 14q right there and a 12q right there. And if the 14 is positive and the 12 is negative, then that's the way it factors right there. So it is factorable. Eventually I got that. Kind of went off the rails there for a minute. So you have 7q minus 12 times q plus 2 divided by q minus 2. And the q plus 2 and the q minus 2 are not common factors there at all. And so there's nothing I can divide out. And so either one of these last two answers would have ended up being okay there. All right, so textbook homework. So textbook practice, that's kind of what I've been calling it. Because this is, it's not certainly not mandatory, but it is good practice for what we're talking about. And so this is on page 947. Problems 255 through 289, and I would think every other odd would be sufficient right there. But those would be good practice problems. And those practice problems that I assign, I always assign those at the end of every lecture. Those are good problems to go and practice the kinds of things. So I really don't think that the WebAssign homework that I'm giving you is even close to enough for a lot of practice on this kind of material. So I always recommend trying to do some of the textbook homework also. All right, so do any of you have any questions about things I covered today, or do you have just any questions in general here before we shut this down for the day?
No questions here. And then I will probably try to come and see you on Wednesday evening.
Okay, so let me, and speaking of that, Tricia, so let's go back and review this one more time at the very end. Don't forget then that my online office hours are going to be today from 11 to 12 and 8:30 to 9:30 in the evening, and on Sunday from 8:30 to 9:30. Then you can make other appointments if you need to. And then my on-campus hours will be tomorrow from 4 to 6 p.m. and Thursday from 9 to 11 a.m. on the North Harris campus in Winship 115K. So I'd love to have you come by at any of those times, either online or on campus. I'll be happy to help you out, so please take advantage of that. Work hard on that review. The review is the big deal for this test. The more of that review that you can go through before you take the exam, the better. You really need to work through the entire review, and you need to be able to work as many of those problems as you can without any notes or any book or anybody helping you, right? The more you can do like that, the better off you're going to be on the test. Because on the test, you won't have anybody helping you either. So, all right, so with that in mind, don't hesitate to come by for help. Otherwise, have a great day. Good luck on the test coming up, and hopefully I'll be in touch with you over the next few days.
Thank you. Have a good one.
Thank you.
Thank you. Thank you.
All right, take care, everybody.